Hello everyone. We are pleased to have this opportunity to present our work on the development of a method for evaluating the urban green infrastructure, based on the ANP, Analytic Network Process Method, to highlight the role of carbon sequestration in achieving urban health in new cities. Let's start by putting yourselves in the context of our project, whose research theme is the urban green infrastructure. The subject is carbon sequestration ecosystem service. The case study is the new town Mabine Outer in progress. The focus of the research is strategic planning for urban health. The objective of the research is the development of a method for evaluating the green infrastructure, for the implementation of a decision-making tool for optimizing carbon sequestration by urban green infrastructures. The urban green grid represents the plant infrastructure of the urban system on which the urban biodiversity clung. It supports plant and animal species and offers them habitat, mobility, and security, all qualitative parameters that provide a good functioning of the urban ecosystem. However, cities in recent years have undergone spatial, social, economic and above all, environmental changes. These considerable transformations make the form of urban production unable to cope with current urban demand, and therefore air quality is at constant risk of suffering these degrading factors in all weakness. The green infrastructure on an urban scale offers residents several goods and services resulting mainly from the proper ecosystem functioning of the biodiversity it contains. The conventional definition of the concept of ecosystem services currently adopted by the scientific community considers a service as the benefit that a functional ecosystem offers to human, whether in terms of support, supply, regulation or downright cultural. These services are economic when we talk about the monetary value provided by the urban green fabric, social value in terms of aesthetic and health cultural goods, or environmental, in this case climate regulations that green infrastructure ecosystems can provide in the urban environment. Urban vegetation is an important reservoir in the carbon cycle of urban ecosystems, however natural carbon sequestration has been recognized as a support ecosystem service since 2009. Our objectives revolve around a definition of processes and proceedings relating to carbon sequestration ecosystem service, a development of an assessment method based on several tools, an evaluation of the green infrastructure of the new town Mabine Outer, a provision of a decision-making tool for the integration of carbon sequestration into the urban green infrastructure project, and a structuring of a strategic approach of urban planning for the urban health. The project of the new city is part of the philosophy of SNAT 2030, which calls for a control of the growth of the coast by ensuring a more qualitative development. This mega project should have a lasting impact on the entire Anabar region, and indeed give it the functions of the city as a space for the creation and multiplication of wealth, a space for cultural creativity and national solidarity, and a space where economic growth, social solidarity and environmental preservation are combined. The project owner's ambition today is to be able to integrate into the planned local projects all the components of sustainable development, balance between the short and the long term, reconciling economic, social, and environmental requirements, and considering local and global development issues. The new city Mabine Outer is in Anabar, the capital of eastern Algeria coastline. With a perimeter of 3,507 hectares and a population reaching 260,000 inhabitants, the case study city will present a green grid satisfying the ambitions of the local authorities to develop a green and sustainable city. The green fabric of the new city Mabine Outer will represent more than 27% of the city's surface spread over 11 districts, with an average of about 23% of green spaces per district. The area studied is mainly covered by dense and sparsely dense scrubland that dominates most of the area, estimated at 1,095 hectares or 71% of the overall plant space, and an herbaceous stratum with a considerable area of 216 hectares reaching 14%. The rest of the area is occupied by agricultural land and orchards mainly composed of fruit trees with an occupancy rate of 11% of the study perimeter. The method used is that of Analytic Network Process, ANP, a general form of AHP, Analytic Hierarchy Process. It is an appropriate approach to the project management for success in organizational sustainability. Analytic network and analytic hierarchy processes are the multi-criteria decision-making techniques, MCDM, that enable decision-maker to prioritize a discrete set of alternatives. ANP does not assume that the alternatives, attributes, and criteria are independent from each other. It has a network structure that is composed of subnetworks and submodels. We wanted in this study to combine between analytic network process and Lazarsfeld method dated 1958, which consists in decomposing one or more concepts into dimensions and indicators using conceptual analysis. It will make it possible to disclose the different variables related to this concept and have a certain consistency of the conceptual framework. From the indicators we proceed to a normalization, then to an aggregation to have different indices. The urban green infrastructure, as a support for air quality insurance for optimal carbon sequestration, has three main dimensions: green density, water load, and soil consistency. These same dimensions represent the different script writing criteria to be analyzed by the ANP for the planning of the green infrastructure. By Lazarsfeld's method, each dimension would be disaggregated into indicators. For example, the green density is disaggregated into two indicators, that of chlorophyll saturation and this of relative humidity. Indicators have the rank of sub-criteria in the ANP process. Indices, or also alternatives, are the results of aggregation of the different indicators. In fact, here Lazarsfeld's method serves to build the conceptual framework structuring assessment, while the ANP provides the weight of each dimension or indicator. They are exploited in a complementary way. The peculiarity that the ANP had to be used is that the criteria are never independent. For this, an additional analysis aimed at determining all the interdependencies that bind assessment framework is elaborated. For the criteria, also saying dimensions, we speak of carbon storage processes that are distinguished in transversal processes such as photosynthesis, and self-processes as growth of vegetation. These processes are thus the subject of a structured analysis to integrate their prioritization matrices into the ANP as a submodel. The same goes for the subcriteria, just that the interdependencies here, on a more detailed scale, present the different proceedings of reducing carbon emissions, and which are evaluated in relation to the indicators and their relationship with the dimensions from which they result. We can speak, for example, of photosynthesis, which mobilizes the proceedings of hydration and dehydration to ensure the self-growth of the plant, the decomposition which links between vegetation and soil, and the transpiration integrating green and blue infrastructure. The results are presented in the form of a global map showing the nuances of each patch of the urban green infrastructure and its capacity in carbon sequestration. Note on these two maps of urban green infrastructure assessment, the one on the left shows the sequestration capacity weighted by the ANP, while the one on the right is of an unweighted sequestration evaluation. The ANP has optimized the evaluation results, whether for the classification in order of capacity of the various isolated patches of the green infrastructure, or in relation to the overall values of the sequestration capacity of the latter, which have been rationalized by the ANP. The ANP also mainly minimized the variance of the values of the carbon sequestration capacity, hence an increase in accuracy of results using this method. Finally, to have a better prospection of the green fabric of the new city Ouder as a tool to establish health quality through carbon emissions reduction in urban air, it can be recommended to define a set of urban green infrastructure criteria and alternatives for carbon sequestration optimization. Highlight the interdependencies existing between criteria. Prioritize different criteria and alternatives with the appropriate analytic process. Choose effective analysis method and weighting process according to the decision finality. Thank you for your attention.